Okay, so we're going to go over quadratic relations. There's three major forms for a quadratic relation, okay? This is called the standard form, where you have coefficients a, b, and c, and these are our main variables. We have a factored form, which can be of the exact same equation, just it looks different. We still have the same a's above, but this time we have two letters called r and s in our factored form. And then there's vertex form, which again we have an a. So in all three versions we have the same number for a, but this one deals with two different variables again, an h and a k. Each of them are set up to help us do something better. Okay. From standard form, we can find our y-intercept very quickly. Okay. So keep that in mind. C will be your y-intercept. And that's good. If we're in standard form, we can instantly look at the equation and figure out what a y-intercept will be. Okay. In factored form, we actually kind of discover what the x-intercepts are going to be. Okay. These will tell us our x-intercepts. They're not exact, but the r and the s are roughly what they are, and I'll explain to them how we find from there. And then finally, in our vertex form, which makes sense, these letters will represent our vertex. Specifically, the x and y values of the vertex are directly corresponding to h and k. Okay? So that's why we have all three different forms, so we can look at it and be able to tell in terms of graphing, instead of having to constantly plug numbers in and out. Now, there's different ways to go from one to the other. We're just going to focus on, I think today, going from vertex to standard. Okay, and in order to do that, we expand and simplify. Expand and simplify. And then we're going to learn also standard to factored form, and in order to do that, we factor something. Okay, which the name makes pretty much sense to. Okay, so this is kind of like a flow chart, and we're going to talk about why each of these is good and what we can get from them. Most of the time, we are going to see things in standard form when we get an equation. We're going to have to work from there. Okay, but we'll go through a couple examples of the very first thing. We're going to go through expanding and simplifying, so going from specifically vertex form to standard form. And just as a side note, the process from going to vertex form to standard form, which is our expand and simplify, is the exact same process as going from factored back to standard. It's also called expanding and simplifying. Okay, so kind of we can learn two from this way. It's a little harder to go from standard to other types of forms. And that's where it gets a little difficult. Okay, so we'll jump to the next page here. Okay, so example number one, they've given us this equation here, y is equal to x minus 2 squared plus 1. First thing I need to recognize, is this similar, or is it in standard, factored, or vertex form? Factored will have two sets of brackets. How many sets of brackets does this have? One. Vertex, that's right. We have a vertex and a squared, sorry, our brackets with squared. We have our k value, which would be 1, and technically there's no number here, so what would our a value be? 1. Yeah, that's right, there's a 1 there for our a value. So I can actually take this, right, and I know that this would be my a, this here is my h, and this is my k value. So we know we're in vertex form. Okay. Now, our goal is going to be to go to standard form. Okay. In standard form, we need to expand and simplify. So it's good we realize we're in factored form. It's actually a little easier to explain what we're about to do if we do the version of factored to standard. So I'm going to put another question up, and then we'll get back to this. I just wanted to make sure that we could recognize what form we're in. Let's say now I have y is equal to 3x plus 1, x minus 2. What form is this style in? Yes, this one's in our factored form, right? We know our a value, and these can be considered our r and our s, okay? So our a value is our 3. Now, this is called expanding and simplifying. Okay? I'm not sure if you've seen this before, but they either call it the rainbow method or FOIL. Have you heard of FOIL at all?
Maybe just cross multiply. Well, not cross multiply, but put x into x and x into 2.
Yes, that's right. So one of the methods they call is kind of like the rainbow method. So what we do here is we're going to deal with our brackets first. That's our bed mass. Okay, we're going to multiply what's in the brackets. We have x, and x needs to be multiplied by both terms in the other bracket. So we do x times x and x times -2. By that same idea, the 1 also needs to be multiplied by both. So we 1 times x and 1 times -2. So my next line will read y is equal to, I haven't done anything with 3, so I leave 3. Well, we leave 3 on the outside. We have, yeah, x squared, yeah, that's right. X times -2.
-2x.
Good. And then again, +1 times x.
1x.
And +1 times -2. Good. Now again, we always work with it's in the brackets. Can I simplify any of these terms?
The 2 x's.
Yeah, our 2x terms can be simplified. So my next line will read y equals 3. X squared. What will these become?
-1x.
Yeah, and then -2. Okay, but let's talk about like terms. This is x to the power of 2, x to the power of 1, and there's no x. Can I actually do any combining with these?
No.
Not really, no, I can't, because each of the variables has a different exponent. So these are just as simplified as it gets. The only other thing I do want to do is very similar to what we did up here, but instead of having 2 numbers to multiply into both, I just have 1 number that needs to be multiplied into all of the numbers in the brackets. It's called distributive property, which is exactly what we did above. This is also called distributive property, it's just there's more numbers involved. This one's a little simpler. We just multiply the 3 by each of the terms in the brackets. So 3 times x squared is going to give us
3x.
3 times -1x,
-3x.
and -2 times +3.
-6.
Now, what form does this look like?
Standard.
That's right. We are now in standard form. We expanded and simplified, and we've got to standard form now. That was our goal in this process. So, remember, we started with vertex form, and I changed the question into factor. Let's put a couple titles on here. Okay. So this was a factored form. This is our vertex. And we expanded and simplified, and we got into our standard form. Okay. Now, here's a goal. We want to actually do the same thing with our vertex form, but the question is a little different looking, right? So we'll call this, this was example 2. Going back to example 1 again. Y is equal to x minus 2 squared plus 1. Let's see if we can work with this. Okay. What's happening here is I have a bracket and then I have a square. Well, say I had 3 squared. What that really means is I take the base and I multiply it by itself 2 times. So what, in order to work on the expanding simplifying, it's the exact same idea, except that we have brackets. So I actually repeat the bracket, x minus 2 times x minus 2, and then we have the plus 1 outside. Now this plus 1 is very different than the 3 at the front of the brackets. This is just an addition, so it'll be added at the end. The 3 here meant multiplication. I don't actually have a term here, so I don't have to multiply in anything after. So again, we do our distributive property or the rainbow method we talked about.
So y equals x squared.
Okay, good. You're already jumping ahead. Great. Y equals x squared.
And then -2x.
Yeah.
And then -2x.
Good.
And then -2 squared. And then yeah, -4.
Close. What's a negative times a negative? Yeah, so positive. Good. And then we still have that plus 1 on the outside. We'll leave it there. Good. So I'm just going to, for note's sake, you multiplied those two, and then you multiplied these two. Excellent. Let's combine our like terms. Now, our like terms, there's actually more than one pair. What is a pair of like terms in here?
Negative 2x.
Yeah, those are both like terms. Any other like terms?
4 plus 4.
Yes, good. Those are also like terms. So we're going to end up combining both of those. So what is our final answer here going to read? Y equals
x squared minus 4x.
Good.
Plus 5.
Yeah. And what form are we in? Standard again. So same idea. And standard again. The only difference was from factored, it's already laid out 2 sets of brackets for us. In Vertex, we have to remember to set it up with 2 sets of brackets. There's just one more step to it in our Vertex form. Okay? Does that idea make sense for expanding and simplifying? Yeah. Okay. So we're kind of moving on now. We'll call this example 3. This is a different topic now. We're getting into factoring. There's a second part of what we were talking about before. To go from standard to factor, we use something called factoring. No, it's not written so nice. What form are we in right now? To start this off. Yeah, standard. You know what I'm going to do? I'm going to put a y equals, because technically it is. We're in our standard form right now, and our goal is to get into factor form. Now, there's several ways to factor something. We're going to go through about 3 different versions of them. Okay. The first one, what we'll do is we'll use something called Algebra Tiles. So I'm going to need a little room for this. Just give me a second. I'm going to write this up here, and I'm going to put some Algebra Tiles up so we can see it. Okay. So you noticed I put a whole bunch of blocks, or tiles they call them, Algebra Tiles. These are our tools. They're not actually a part of the question right now. We're just going to pull them out from our toolbox, we'll call this. So what I'm going to do is, in order to figure this out, is I'm going to take a look at what I have. I have how many x squareds? 1. So I'm going to pull 1x squared out of here. So we got 1x squared. How many x's do I have? 8. I have 8 x's, okay? So that's pretty important. So what we're going to do here is we're going to pull out 8 x's in this question. So we have 1, 2, 3, and finally 8. Okay? And what's important to notice, were they positive or negative? Positive. So I used the green, which is our positive tile. The white ones were our negative. And finally, how many constant terms or ones? I have 12 ones. So I'm going to take out 12 of these. 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12. Should show smaller numbers. Okay. Anyways, in order to factor this, I need to set this up so that I can make some kind of 4-sided shape, actually. We're looking for either a square or a rectangle. So we're going to put these all together. Okay, so it might take me a little trial and error for this, but I pull an X, and these blocks kind of stack on top of each other. Okay, so we have one there. I can put another here, another here. I'm going to stack them, and then I'm going to turn them around after to see what we can actually get out of this. Okay, so when I stack these, if I happen to stack them, I know they're not exactly flush, but imagine I actually have dexterity, and I'm able to do this. I want you to just get used to this idea that, hey, if you look at this right now, technically this is a larger 4-sided shape. Okay? Does that idea kind of make sense? I've made a 4-sided shape out of this? Okay, but I haven't really included the ones. And in order to include them, once I get 12 of them out here, even if I slid them all down the side, it's not quite, no, it's not going to be even. So I have to make a different type of shape. Okay, so I'm kind of looking around at this, and sometimes this takes a bit, especially with factoring. But I'm going to tell you that you can also turn these. Okay? Our goal is to build on the x squared. So I'm going to turn 2 of them. I'm going to take a look at this. Now what I'm looking for is to fill in a space like this. Okay? And we just got to remember how many blocks we have. So I have the number 8 here. Okay, I have 8 of these tiles, and when I stack them 2 by 6, okay, that's right, we're going to get to 12. So in other words, one way to organize this is to think what numbers add up to 8, okay, and we call this our B term. Okay, so what 2 terms are going to add up to our B term, and they're also going to multiply to our, sorry, C is not usually in red, C is usually in green, so I'm going to switch that. But they multiply to our C term. That's right. Okay. 6 and 2 happen to work in this case. So what I've done here is I've stacked 1, 2, 3, 4, 5, 6 blocks upwards, or I could have done them sideways, it doesn't really matter. And I stacked the other 2 there. And let's just make sure this works in terms of making a shape. I stack one of these blocks, 2, 3, trying to correct my mistakes as I go through, 4, 5, 6, and 1. If you did it with your hands, you'd be much better at it. 3, 4, 5, 6. These usually, yeah, they fit a little nicer together with real ones. But do you see the general idea now? I've now made a shape. That's equal. Yeah, that's equal. It's roughly a 4-sided shape, okay? This is very important. These numbers we've discovered. So now looking at this, think of it like area. We're looking at area of a shape, okay? So I have an area here, and I need to figure out the length and the width of this area. Well, the length of this here is an x. That's how long across this is. It is an x. So we're going to put an x. And then the length of each of these is technically a 1. So how many 1s did we use there? 2. So the entire length altogether is x, not 2x, but x plus 2. Right? Those 1s are just considered constant terms. Same idea here. This width is how much? Yeah, it's just 1x. And each of these widths is how many?
6 1s.
Yeah, 6 1s. So we put the number 6, and we're essentially adding them together. So the width of this shape is x plus 6, and the length of this shape is x plus 2. So in our factored form, y equals, remember factored form deals with 2 brackets? Well, each of these terms is going to be our brackets. So let's take them like that sideways. So we have x plus 2 and x plus 6. That is our factored form, kind of using our algebra tiles.
So you have to get it into standard form.
No, we were in standard form to start. Remember? So our goal was to go to factored form, so we factored it using our algebra tiles. Okay, so that's using algebra tiles, which can be difficult when numbers get big because you're going to need a lot of tiles and stuff like that. But always remember this little trick here. This is B plus C. Okay? Okay. Exact same question here. We're going through this. Another style of factoring is exactly what we had stated before. Remember, this is our B, this is our C, and this is our A term, right? One of the things you do in order to solve this is I want you to focus on what is our A term here? 1. Yeah, the 1. The 1 in front of it is technically our A term. And because it's 1, we're able to do a really fast style of factoring. Now, if it's not 1, we have to do something a little more complex. I'm going through it. Okay? And technically what I can do is I can show you the method. I'll show you the method so that it works for each. So that same idea we were talking about before, and I guess we should go back and add to it after with the algebra tiles, is we're going to be looking for, again, 2 terms that add to B. Okay. The only difference is, in this case, we're also looking for those same 2 terms are going to multiply to A times C. a little different. Okay. Now I'm going to jump back in our algebra tiles. The reason we didn't do it that way, and it actually should be C times A. So make sure this is a little cleaner. It should be C times A. The reason it worked in this version is because what was our A term? 1. So when we figured out it was 2 by 6, right? We did 1 times 12. What did we get? 12. So we still ended up with 12. We still needed two numbers that added to B and multiplied to 12. If A is a different number, we're going to have a larger value here. That's the idea. Right now we're working with when A is just 1, but it's important to know that this method will always work. Just always remember they got to multiply to A times C. So we jump to our next page. We have our A times C. Well, same idea. Our A value is 1, and our C value is 12. So we're looking for two numbers that multiply to what? 12 to 12. And what's our B term? 8. That's right. So let's reset this up. We're looking for two numbers that are going to add to the number 8, and those same two terms, nope, won't add. They're going to multiply.
So 2 plus 6, 2 times 6.
2 plus 6. 2 times 6. Perfect. So this method, we don't need any tiles. What we do is we just jump right ahead. We go into our factored form. Okay. And what we do know here, sorry, no, we're not going to jump right into our factored form. That's a fast method. I'm going to show you the method that always works. Those two terms, what we do with them is we're going to split this equation with them. So how the equation you normally said yx squared plus 8x plus 12. Well, 2 and 6, I'm going to split 8x into 6x plus 2x. It's technically the exact same thing, right? 2x and 6x are the exact same thing. Okay? So my next line reads y equals x squared plus 6x plus 2x plus 12. This is called decomposition. So we're decomposing the middle term. We're splitting it in two. Now what we're doing is something called common factoring. Okay. Which we're supposed to have looked at before. Now in common factoring, I want you to think of it like this. I have some imaginary brackets around the first two terms, and I have some imaginary brackets around the second two terms. Doesn't matter how we split it, this is always going to work. What we need to do now is find common factors. So I'm looking for a common factor of the first two. Okay. Now in terms of the coefficient, 1 and 6, well, the only factor of 1 and 6 is 1. That's right. But if you do notice, we have an x squared and an x. So what can I take out of each of those? An x. So altogether, what can I take out? I can take out 1x.
So then it'll be x plus 6.
Yes, that's right. So we'll do this one step at a time. Excellent. That 1x comes to the outside of our brackets. Okay. And inside them, we have x plus 6. Good. I'm going to leave the other part. We haven't done anything to it yet. You'll start to get good enough if you can do this all in one step. Now again, think about two imaginary brackets. Or sorry,
so
sets.
Just be 2 plus 12.
That's right. We can take out, well, no, sorry. What can we take out of this? Is there an x on the 12 term?
No.
No, so we can't take
so
an x out of it.
2.
Just the 2.
So that would be x plus
What
12.
is 12 divided by 2?
Well, x plus 6.
Good. Plus 6. We took out the number 2, right? Our positive 2 here. And we're left with x plus 6. Now this is a very important part. The goal was to make two sets of brackets that are the same. When we have two sets of the brackets the same, we can pull those out together. So in other words, what happens now is one of the brackets is going to say x plus 6. We're jumping into our factored form. The other bracket is going to be the two common terms. 1x plus 2, or just x plus 2. So if you remember, whether we did algebra tiles or decomposition, we ended up with x plus 6 and x plus 2 as both of our answers. decomposition, this will work even if A is not 1. That will always work. That factoring and then taking the common factors out and then making two sets of brackets that are the same, and we just put the other two into their own separate bracket. Does that last step make sense? For the most part? Okay. Let's do one other style. Okay. Last method here. Again, we have to know what our A term is, our B term is, and our C term. Okay? What I'm going to do here, instead of decomposition, all that stuff, I'm going to find the factors of my first term and all of the factors of my last term. Just the absolute values. I don't care if there's negatives and positives and stuff like that yet. We'll deal with that after. So this is technically 1x squared. Well, there's only two numbers that multiply to 1. That's 1 and 1. And to get to x squared, it's, well, 1x and 1x. Those are the only options. Okay, those are the only options I have. I'm just going to put a little rectangle around this. Okay, so that's a pair. Now, there's going to be several pairs for the number 12. We have 1 times 12. We have, yeah, and good. We have 3 sets there. I'm going to put these also into in the rectangle, just because I want you to realize that they're separate columns. So I've set up my separate columns. The goal here, this might seem a little confusing, is we're going to multiply a pair of columns by each other. Then we're going to add the products, which is what they multiply to, and they need to add up to our B term, which is 8x. Okay? So the setup is what's confusing here. Once we have it, it's a very fast method. We're going to do some trial and error. I'm going to try 1 times 1 and 1 times 12x. Well, 1x times 1 is 1x, 1x times 12 is 12x. Can I add this combination, or can any combination of this make 8x? No. Let's try going across. Yeah, well, it's going to give us the same numbers, right? Because these terms are the same. Now, if this had been a number 2, going across will give us different stuff. Okay, but just keep that in mind. So we know the 1 and 12 did not work. That bracket doesn't work. Okay, let's try the next one. Actually, let's just, for argument's sake, let's go to the last one. 1 times 3 and 1 times 4. That gives us 3x and 4x. Is that going to work? No. And if we go across, still not going to work. So we know that doesn't work. So we're down to 1. We do need to test it, but it should work. 1 by 2 and 1 by 6 is going to give us 2x and 6x. Will that work? Yes, we know that'll work. So I'm going to draw these in permanently because this is very important. This is an important part of it, especially when A is not 1. We know we got our 2x and our 6x, so they worked. Great. The reason I've kind of separated these sets of columns is because we're going to go directly into factored form. I don't have to do anything else once I've got these columns set up. I want you to recognize, though, these deal with the first terms. Or in other words, it's going to be the first term in each bracket.
So, yeah, x is first.
Yeah, exactly. Well, it doesn't have to be, but the way we're factoring it's going to be. And these deal with the second terms in the brackets. Okay? So in other words, they fill out those spots there. So my first terms, I throw them in first. It makes it nice and easy. I don't even really need the 1. I can just put x and x, correct?
Yes.
So I got my x's. Now here's the tricky part. Because I multiplied this 1 by the 2, I'll put him here, they actually have to go in opposite brackets. I can't put them in the same bracket. So I did 1 times 2, so I put this x in here. The 2 needs to go in the other bracket. You're right, it's not going to make a difference right now. Okay. And same idea here, I had the 1x and the 6. Well, I put the 1 in here, the 6 has got to go in the other bracket, right? So positive 6. You're right, it made absolutely no difference right now, but I'm going to tell you quickly. So our final answer is, lo and behold, x plus 6, x plus 2, which is exactly what we found every time we've done this, right? If this had been the number 2, and I put the 2 in here, if I did not put the 6 in the opposite bracket and put it in the same, it would not be the right answer. Okay? So because our first 2 terms were the exact same, you're right, it didn't make a difference. But when they're not the exact same, you have to remember that rule that they're supposed to go in opposite brackets. All right. Okay. That's kind of a rule to remember. So we've gone through 3 different methods of finding the exact same thing.